Okay, a couple more examples. Rogowski, page 175. Here's a number 40. So number 40 says y equals e to the 2x squared. All right, so derivative of the outside function is e to the x. So the derivative of e to the x is e to the x. Derivative of e to the 2x squared is e to the 2x squared. All right, so that's doing the derivative of the outside function, even though it looks like I left it the same because e to the x is its own derivative. I kept the inside function the same. Now I will multiply times g prime. G prime is 4x, and that's it. So times 4x. All right, number 46. We have y equals sine of x squared times cosine of x squared. Oh, there's a product and a chain rule. All right, so you have to look at sort of what is the outermost of those ideas. Well, we have the product, and then the chain rule is like inside the product. So we want to look at this as being f, g, and each of my f and g is going to have a chain rule to do it. So I want to look at my y prime being f prime g plus f g prime. So my y prime is, okay, so I'm going to do f prime. So my f prime is going to do the derivative of the outside function, which is cosine, keep the inside the same, x squared, times the derivative of the inside function, which is 2x. Okay, that's just f prime. All right, and then I have to multiply times g. So for g, I'm not going to do anything. I'm just going to keep it as it is, cosine of x squared. All right, so that is g. Then I have to go plus, and to keep it all fitting on my paper, I'm going to just drop down a line and go plus. Now I have to go f g prime. So f is sine of x squared. So sine of x squared. All right, I'm not doing any derivative there, but that's my f. And then I have to have g prime. So for my g prime, since I'm doing a derivative, I got to do derivative of the outside function, which is negative sign, putting a parentheses, so it doesn't look like I'm just subtracting the sign. Keep the inside function the same, x squared. Don't be afraid of writing lots of parentheses. Parentheses are fun. Times the derivative of the inside function, because I'm doing a derivative now, right? So I did the derivative of the outside function, kept the inside function the same, and then times the derivative of the inside function. I'll call it h prime since I already have a g. All right, so that's what I got. When you have a negative like in the middle of a factor, it's pretty much nice to write that, to rewrite that. Also, we have some terms we can really combine, like cosine of x squared times cosine of x squared is cosine squared of x squared. And it's also traditional to put the polynomial in front. So 2x cosine squared x squared, and then I'll bring that negative all the way out the front, put the 2x here, and then I'm going to have sine squared x squared. Sine squared x squared. That's pretty interesting. I didn't even expect that. If you want, factor out the 2x. There's nothing special about that. Yeah. If you got cosine squared plus sine squared, that would be nice, because then you could just make it 1. All right, but we don't have minus. By the way, there's an identity that you can work with this, but let's just quit while we're ahead, shall we? All right, that's number 46. Number 50. This is all from the Rogowski. So I have y equals, what kind of a function is this? Sine of cosine of sine of x. All right, there's no real application of anything where this would come up. They're just showing off that you can do it. All right, so y prime is, okay, derivative of the outside, derivative of sine is cosine. Keep the inside function the same. I got cosine of sine. Cosine of sine. All right, now I have to go times the derivative of the inside, but the inside is also a chain rule. So to do the derivative of the inside, I'm going to do the derivative of the outside function, the outside of the inside. I get negative sine. Keep the inside the same, sine x. That's keeping the inside function the same. And then I have to go times the derivative of the inside function, which is cosine x. So sine of sine is not sine squared. You should know that. Sine of sine. Remember, if I do the sine of pi over 2 is 1, and then do the sine of 1, that's not the same as sine squared of pi over 2, which is 1. All right, the sine of pi over 2 will be sine of 1, which is an irrational number. All right, so I guess the only nice thing we can do is bring the negative out to the front, and then we have negative cosine of sine of x, which cannot simplify in any way, times sine of x, which cannot simplify in any way, times cosine of x. There you go. That's number 50. All right, so I'm going to assign Rogowski, page 175, this is our homework, number 29 through 51 odd. But wait, there's more, because I'm going to also do some problems from the book.